Hello folks, and welcome to the channel, or welcome back. And in this video we're going to be looking at the ignition system of a standard 4-cylinder car, and I'm going to be using my Mini to give you an example on how you can adjust the timing. We'll be looking on how it's working. We'll be looking at the advance, the static, the dynamic advance, and the dwell angle of the breaker points. So there's going to be a little bit of theory, and I'm going to use a whiteboard for that, and then we're going to get into the practical side of that. So without any further ado, let's start. So let us start with the basic principle of an ignition system on a 4, 6 or 8 cylinder. It doesn't really matter how many cylinders you have, but fitted with a high tension coil, and this is the high tension coil, and a standard distributor. And I have here the ignition coil, that's that one. And of course we have the distributor, which is sitting right here. That's a distributor. So we have a battery, of course, because we always need battery power, and the battery is connected to the ground at one side, and I'm using a negative earth example here, but it could be a positive earth, it doesn't really matter. The other pole of the battery is then connected to the positive side of the coil, and inside the coil we have a primary and a secondary winding. The plus side of the battery connects to the plus side of the primary coil, and the other side of the coil is then connected to your distributor, to the breaker points, and the breaker points could be mechanical or electronic, that doesn't really matter. The breaker points is nothing more than a contact that is going to open and close, and it's going to open up based on the notches on that shaft. So when the shaft is spinning and that shaft is driven typically by your camshaft or your crankshaft, then if that rotates, the points will open and close, and that's going to become important when we start talking about the dwell angle. And then the other side of the breaker points are connected to the ground. On the secondary winding of the high tension coil, which is this output, we will find the high tension lead. And the high tension lead typically connects to your distributor, which is the middle connector of your distributor, right? This kind right here in the middle. So not the one that is going to the individual spark plugs. And inside the distributor we have the rotor, which is this part, which then will distribute the spark to the relevant spark plug. And of course this is the lead going to the spark plug itself, and we have this 4 times or 6 times or 8 times. So how does this work? Well, the principle is simple. If the contact is closed, then current will flow from the positive side of the battery through the primary winding of the ignition coil, through the breaker points to the ground. And that current is going to generate a magnetic flux inside the ignition coil. Now, once the notch starts to turn, it's going to lift that contact, and the contact will open up. And when the contact is opened up, the current flow is broken. It's stopped. And that causes an induction inside the high tension coil. The secondary winding will get an induction and will cause a high voltage to be produced. And the high voltage, which is now happening through the induction, is passed to the middle part of the distributor cap. And then the rotor inside the distributor cap is then pointing to a specific cylinder. And then the high tension lead is then going to the relevant spark plug, and then we have a spark. Now, the notch will of course continue to turn, and what happens then is that the switch is closing again, current is restored from the battery all the way through the primary, we're building up another magnetic flux in the high tension coil, and then the notch continues to run, it opens up the contacts again, and then we are back to the initial situation whereby the current is stopped, we get an induction in the secondary winding, high tension is then produced. Meanwhile, the rotor has moved to the next cylinder, and then we get ignition on the next spark plug. And this is how that works. So pretty simple, nothing special to that. However, there are a few important things to talk about, and the first thing we need to talk about is the dwell angle. So you probably wonder why I'm talking about the overall operation of an ignition and why I'm talking about a dwell angle. Well, there's a lot of things that must be correct before you even start to adjust the timing on your ignition system. So you have to have the right fuel to air ratio on your engine. So that means that the carburetor has to be properly adjusted. You have to have cylinders that are having the proper compression. You should have the proper valve clearance, you should have the proper valve timing, and you should also have the proper fuel in the car, and the car should be at operating temperature, and the breaker points should have the right dwell angle, because with all that it doesn't make sense to start adjusting your timing. So there are a couple of preconditions. So now let's focus on the dwell angle, what that is and how big that has to be, because that is an important factor before you start to adjust the timing. What is the dwell angle on the breaker points? So here we have the breaker points. This is the notch inside the distributor, and what I'm showing here is a notch with 4 high points. So this notch is rotating, which is driven by your camshaft or your crankshaft, and it's about half the RPM of your crankshaft. That's the speed typically on a 4-cylinder distributor. So this is rotating, and while this is rotating, it's going to open up these points on the notch areas, and it's going to let the contact breaker points close whenever the notch has passed this little lever point here. So we can say that for a full 360-degree rotation, we will have 4 times an opening of the breaker points. And that's what I show here. O stands for open and C stands for closed. So while the notch is rotating, we can then say within 360 degrees, which is a full rotation, that the contacts will be closed for a certain amount of time. And that time is what we call the dwell angle. That's what we call that. Now typically that is around 50 degrees. Now the question is, how can you adjust it and how can you check it? Well, adjusting it is simple. You will have to move the engine into a position whereby the notch is opening up the breaker points to their maximum, and then you will measure the gap in here with a gauge and set to the proper gap that your specification says for your specific engine. And now you're probably why is the dwell angle so important? Well, it is important because the magnetic flux in the coil has to be built up, and to allow sufficient magnetic flux in the coil, you have to have a certain amount of current that can flow through the coil. And if that time is too short, in other words, if the dwell angle is too small, then not enough current flows through that primary winding of the high tension coil, and the magnetic flux is low. So whenever the points then open up, you're going to have a poor induction, and your spark will be of poor quality. So you're going to have a weak spark. So weak sparks can be caused by the wrong dwell angle. Now, if you make the dwell angle too long, then you have another problem. Then you have enough current through the coil to build this magnetic flux, but then the problem is that because the opening is so short, you actually, of the breaker points, you actually are cutting short on the actual spark, because they close sooner, the current starts to flow again, and the kind of discharge of that secondary winding on the high tension lead is kind of interrupted. So again, you have an incomplete spark time, and it's no good. So you have to have that right. And as I said before, typically that's around 50 degrees of dwell angle, but it varies from car to car. So I'm going to show you now on how you can actually adjust these breaker points, and then we'll measure with a strobe light and a dwell meter the dwell angle on this Mini. This is an old distributor that I've just placed on a side stand so we can have a closer look. I took the cap off, and normally you would find the distributor cap on top of that, which would be connected and locked down with these springs. So I took that off so we can have a look inside. This is the rotor, which is going to distribute the high tension spark, which is coming from the high tension coil on the top here, and it's going to then distribute it to the relevant spark plug relating to whatever lead it is pointing to. And then inside we got the breaker points. So the breaker points are right there, and if the notch is turning, you can see them opening up and closing. And the time that they are closed is what we call the dwell angle. Adjusting the dwell angle is easy. It's a manual thing. You need a gauge of a certain thickness, and I'm using a 0.3 millimeter gauge, but that depends on your engine specification, and I know in general that 0.3 is about right. So I'm going to rotate now the engine until the notch is pushing these breaker points to the maximum possible opening. And then I will use my gauge and stick it in there and feel that it goes in properly. If it fits like this, then it's properly adjusted. If not, then you will have to release the screws and adjust actually the breaker points. And I'm gonna just try that, and hopefully you can see it. And let me just open that up here for a second. And then you can actually put the screwdriver in and move these points around, as you see. See? So that's what you can do. So that's how you adjust the gap. So you adjust the gap, stick it in there, and then just move the points until you have a good fit. And that's all there is to it, to adjust the breaker points. And once you've done this, then you can double check it on the car itself and measure the dwell angle. I'm having here my strobe light with a dwell angle meter on it. I've set it to dwell angle, and what I've done is I hooked it up to the plus 12 volts, so this needs plus 12 volts to be able to work. And then I have another clamp, which is this clamp, which is the green one. That's the one that's supposed to go to the negative side of your high tension coil. So the lead go into your distributor, and that's going to measure actually the dwell angle. So let me hook that up, and then we start up the car, and then we can actually measure the dwell angle. But I need my glasses to do it. That's the problem of getting old, that you see diddly squat. So let me hook that up. Right, it's connected, and I'm just gonna leave that here for now. So we'll check it as soon as the engine is running. So let me crank it up and see what happens. All right, so we got the engine running, and what I see here is that the dwell angle is around 46 degrees. That's exactly what we wanted. Here you have the actual dwell angle of the engine while it's running on idle, and you will see that it's not going to change. I have an angle of 46.4. It shouldn't change at all. It might change just a little bit. But that's very minor. So this is good. This is a proper dwell angle. Now we know already what the dwell angle is, how we can measure it, how we can adjust it. So that's the first step. Before we now get into the actual timing adjustment, we need to look at a few other things and making sure that everything else, which I call pre-checks, is in a good condition. So the engine has to be warm, and you have to have, of course, proper compression on all the cylinders, otherwise it doesn't make sense to adjust the ignition timing, and you should fix these issues first. You have to have the valve timing okay, the valve clearance okay. You should have the proper AFR, air-fuel ratio, which is a 14:1 mixture on your carburetor, so your carbon dioxide should be good on the emission. Typically that's around 3.5, 2.5, whatever type of engine you have. You should have set the dwell angle. We just did that and we checked it, and that you set by adjusting the breaker points. If you have mechanical breaker points, if you have electronic breaker points, then of course you cannot set the dwell angle. In most cases you cannot. The distributor has to be in a good condition, obviously the rotor as well, and then all the high tension leads on the coil and going towards the spark plugs have to be all in a good condition, not broken, no cuts, really good stuff. And the spark plugs have to be good, and of course the gap on them has to be adjusted. Once you have all this, then we can start talking about adjusting the timing. Setting the timing on the ignition is nothing more than adjusting the moment in time when the spark happens, when we are igniting that air-fuel mixture. And that should happen at the right moment to have the maximum power and the highest efficiency. We all know that the pistons are going up and down, and if it's a four-stroke, the piston will suck in air and fuel through the carburetor when it's going down, and then it's coming back up, and now we have the compression cycle. And when it hits the top, that center, that's the moment in time. We want to push it violently back down by causing an explosion of the air and fuel mixture by igniting it with a spark. You can compare it with a kid on a swing. And if you want to push the kit on the swing in the best possible way, you're going to stand behind it and you're going to move the kit back and forth. And once the kit comes up to you, Then you push it when it's at about the point where it's going to return, and then you push it. And then you have the most effect of you pushing the swing. Well, it's the same thing here with an engine. If the piston is at top dead center, is at the highest compression rate, that's the moment in time you want that mixture of gas and fuel to explode and have the peak of that explosion pushing down that piston. You don't want to push the piston down too early, because then it's going to go in the other direction, and you don't want the piston to be pushed down by that explosion when it's already on its way down after the compression stroke. So it is very important to develop the proper amount of power that we do that ignition at the right time. However, there is a small problem. And the problem that we are having is that the air-fuel mixture does not explode immediately. It needs kind of a little bit of a run-in time, then it hits its peak, and then it's going to come down again. And it's exactly that peak that we want to have at the right moment in time. So that actually means with a running engine, we might have to advance the spark. We want to have the spark and ignite that mixture prior to the piston hitting the top dead center. So by the time that the fuel burning or that explosion starts to creep up and hits this peak, we will have actually the piston just on top of the top dead center, and then we can push it down violently with all the power that we have left on that explosion. And that is so critical. That's why we need to have advance. Now the question is, how much advance do we need? And how many degrees advance we need to have depends a bit on how many RPMs we are running. It depends on the engine type. It depends on the fuel you're running, because some fuel is having different burning patterns than other fuels. So there's a lot of parameters that will affect the advance that is required. Now, there are two types of advance. There's the static advance and there's the dynamic advance. And I'm going to try to explain you the difference between the two, because we will have to adjust the static advance and we'll have to verify and potentially adjust the dynamic advance. What I've drawn on the board here is the curve on how the fuel explodes once it is ignited. And you can see nothing happens. We have the spark, and now we ignite the fuel while the piston is at top dead center, and it builds up that strength of that explosion. It has a top, and then it burns out and it's kind of flat again and ready for the next cycle. So this happens within a certain time frame, and that pulse doesn't change. It's always the same. It's the nature of that fuel. It's the nature of its explosion characteristic. Below that, I have the curve of the piston travel, the piston that's in the cylinder that we're talking about. So the piston starts off at bottom dead center, BDC. The piston travels up, and this is like a linear curve going up, and it hits the top dead center. It dwells around the top dead center, and then it's going to go down again. And it does this within a certain time frame. Now that time frame depends on how fast the engine is running. So if we're running on high RPMs, that time will be very short. If you're running on idle, that time will be much longer. So now we have kind of a problem, because the time for the fuel burning is always the same, but the time for the piston movement is an issue. So under idle conditions, we could say that we're going to ignite the fuel somewhere around this point here, right? So just before the piston hits top dead center, we want to ignite the fuel so that the peak of the burning power is hitting the piston while it's going down just after top dead center. That's why you want it to happen. And that's why we need to set static advance. So we're going to call that static advance. Now, static advance is something for the engine running on idle. Now, once we speed up the RPMs on the motor, we need to move this ignition point more to the left. So we need to provide more advance, because this time is getting smaller. So to keep hitting the same spot. And that's why we're going to give it more advance. So we're going to shift this whole curve more to the left. So in essence, when this speed picks up, because the engine is now running faster, something like this, then we'll have to move this whole curve a bit to that side. So that peak is still in the right spot. Now that's what we're going to call the dynamic advance. Now, the first thing we're going to do is adjust the static advance. Now, typically, that is specified in your owner's manual or the technical specifications of the engine. Now, for the Mini that I have, I tend to go to around 10 degrees, 10 to 12 degrees advance on the crankshaft. Some people say it should be 5, other people say it should be 12. Again, it all depends on the engine you have. But I like to start off with 10 degrees. And 10 degrees is not going to do any harm to any engine. And you will hear it on the engine how good it's running on idle anyhow. In fact, I don't even mind to go to 14 degrees. It works. Now, it's a different story once we start running on the dynamic advance. Because then we're going to add advance to the static advance, and at the end your final advance is static plus dynamic. And then you may have a bit too much advance. So in principle, the total advance for static plus dynamic should never be more than about 32 to 35 degrees. So this is kind of a rule of thumb. Of course, if you have a race engine, it's going to be different. But for a standard engine, 30 to 35 or 32 to 35 is about the maximum total advance the engine should have at high RPMs. And there are curves that actually show that. And I'm going to try to get a curve in the video afterwards to show you where that is sitting. So, having said that, now we need to look on how we're going to create this dynamic advance, because static advance, installing it is very simple. That you just do by rotating the distributor left or right, depending where the rotation of that rotor is inside. So by rotating the distributor while the engine is running on idle, you can actually adjust the advance. And of course, you're going to need a strobe light for that. And we'll have a look in a few minutes on how you can do that. There are methods that you can do static adjustment, especially when you took an engine completely apart and you put it back together. Then you want to do a static adjustment fully manual without the strobe light, because you don't even know exactly where that pulse has to happen. And that's another method. So in essence, you don't need the strobe light, but you're going to need one for the dynamic adjustment anyhow. So it's always a good investment to buy a good quality strobe light for adjusting the engine. So now let's talk a bit about how we achieve dynamic advance. So static advance, I think that's now clear. We're going to set it fixed to about 10 degrees on this engine. You might set it a bit lower to 5 degrees on yours, but we come back to that on how you might have to readjust this. And again, that depends on your type of engine and your specification on your engine. You can find it in your manual. If you're going to set the static advance, you don't forget to disconnect the vacuum hose if you have a vacuum hose. But we set the timing by actually using a strobe light pointing at the crankshaft pulley or any other marking that you have, and then turning the distributor to the right position until these marks on the pointer and on the crankshaft pulley align up to whatever amount of degrees you want to have. Now, dynamic advance is a bit different. So how are we going to advance this distributor, which is now locked in place with a bolt, to provide more advance depending on the RPMs? So the more RPMs we create on the engine, the more advance we want to have. Advance which is over and above the already static advance. And remember that static plus dynamic advance, we try to keep it below or equal to 35 to 32 degrees. There are two ways of doing dynamic advance. The first one is what we call bob weights, and I'm going to show you what that is all about. And the second one is a vacuum advance, and both can sometimes be combined. So first of all, the bob weights. So let's have a closer look on a distributor on how bob weights are working. So here's our distributor. We took the cap off. So underneath this, we will find the bob weights. And let me open that up and remove the top panel, and then we can actually see it. What I mean with bob weights. Bob weights are nothing special. It's actually two kind of weights that are flying around in the distributor, and through the centrifugal force, they move the whole notch forward, so they create advance on that notch. Oops, I dropped my screwdriver. That's all right. Inside, here it is. You see these moving parts here? These are the bob weights. And look, when they fly open because of the centrifugal force, look what the notch is doing. So if they fly open because of the RPMs, the notch is advancing. And that's exactly what bob weights do. So the faster the engine runs, the more effect you get of the bob weights. So the more centrifugal force you get, the more advance you get on the notch. And that's what they do. Now you might notice that there are springs. There's a large spring and a smaller spring. Now there is a reason for two different springs. The smaller the spring or the lighter the spring load, the faster these bob weights will fly out. And the larger the spring or the heavier the spring or the more force the spring has, the slower the movement will be. And because we want to create a specific curve for advance, so in the beginning we have to have a very steep increase, and then we want to flatten it off. We have a soft spring initially and a harder spring further down on the RPM range. And that's typically how that works. Now, some tuners are going to work on these springs and they will adjust them to create what we call an advance curve. So what I drew up is a typical advance curve whereby on the bottom line we got the RPMs, and on the vertical side we've got the amount of advance in degrees. And typically, as long as the engine is running on idle around 800 to 1000 RPMs, we only talk about the static advance, and in our case we decided to have 10 degrees. But once we accelerate, and the bob weights will fly out, and between 1000 and about, in this case, 3000, we have a pretty steep curve. So we want to have the effect of the bob weights very early. So that means that we shouldn't hold them back with very strong springs. So we're going to have let's call it a primary spring, which is going to be fairly soft, allowing these bob weights to fly out sufficiently, and that the notch is going to advance very quickly, because we're going to advance between 10 degrees and potentially between 20 degrees, let's say. So that's about 10 degrees increase or more. And then from 3000 to 5000 RPM, we don't want to have such a huge increase anymore in terms of advance. I know my figures don't match up too much, but that's what we want to have at that moment in time. We want to have less acceleration or advance actually of the bob weights, and that's why the secondary spring now is coming in, and that is stronger, so the bob weights will have less effect on that. So that's the mechanism that you apply with bob weights with centrifugal force. And depending on how you play with the strength of these springs, you can change this curve more flat, whatever way you want to have that curve. Maybe something like this. It depends on your specific purpose of your engine and what your engine can deal with. So that's very important. Now, one thing which is always very important is that the maximum advance should never be exceeded, because then your engine will start to ping. In other words, you're going to have ignition and the maximum explosion part will happen prior to top dead center, and you're going to start pushing back that piston in the wrong direction where it's coming from, and you don't want that to do. And you can hear that very well on your car. Once you're going uphill and then you floor the pedal, you will hear that pinging sound. That means you have way too much advance, and you have to work on that and reduce it. So how can you reduce that total advance? Actually, well, you do that by lowering down here your static advance. Instead of 10, go to 5. It doesn't matter on idle anyway, but at the end it adds all up when you're in your high RPMs. And that lowering on the static advance will actually lower down the final top advance at high RPMs, so the pinging will be gone. So now we know how bob weights are working and how they create advance. Now the other method is using what we call vacuum. It's a vacuum advance mechanism, and we know that the intake manifold is creating vacuum. And I hooked up a vacuum meter, and then I'm just going to measure the idle vacuum in a second to show you that it does create vacuum, and of course you all know this. And the more RPMs you make, the more vacuum it creates. And if you were now to apply this vacuum to a membrane which is fitted to the distributor, then actually the membrane can then pull out the rod and advance as well the notch in the distributor. And that's the other method that we apply in cars. Vacuum advance, and often you see a combination of bob weights and vacuum advance. This is an example of a distributor with a vacuum advance, and this is the membrane connected to the intake manifold under pressure or vacuum, and whenever the engine is running, it's going to move that membrane inside that way, and as such it's going to pull a little rod inside that will advance the notch inside the distributor. I have hooked up the vacuum hose to the intake manifold, and now let's start the engine. And you actually see the vacuum being created. So that's the kind of vacuum we're going to use now for the distributor to advance it or not. So now that we know how the static advance is working and the dynamic advance is working, it's probably time to start some adjustment on this little Mini here. So I'm going to do first the static adjustment. I'm not going to do the manual static adjustment. I'm going to use a strobe light for that. So as I said before, I do recommend that you have a strobe light. We're going to warm up the engine. We're going to run it at its idle RPMs. I'm going to loosen up the nut that holds down the distributor, and I'm going to point the strobe light to the crankshaft pulley where the mark is on, and also the pointers on the distribution cover. It may be different on your car, but there are always markers on your vehicle where top dead center is, and these are the ones you need to check. Now, I have to say one thing. You can't always trust the markings on a cover that's fitted to protect the distribution chain or something like that. The pointers are not always right, and it's quite often it can be off at 3, 4, 5, and even more degrees. I've seen that before. So you might actually want to check the marking on your flywheel if you have access to it. On the Mini, there is a way to do it. There is an inspection hole that you can look through and find out the markings on your actual flywheel to identify true top dead center. So on the Mini, it's always good to open up that inspection hole. For the people that have a Mini amongst you, this is the inspection hole. Unbolt this a little bit, and then you can flip it open. Now you need to look inside, but for that you need a mirror. I hope you can see it a bit. I have my mirror placed right there at the opening, and you can see the marking on the flywheel. Actually, it says 1.4, and on the top of it you have a little notch, and that's how I've set it. That's your real true top dead center. Move the engine until it's aligned, and then have a double check on the front pulley if everything lines up there as well. If it's not, then you can adjust those things. But okay, for now, let's assume that the markings on, or the pointers on your engine block and the marker on your crankshaft pulley are properly set, that they line up to real top dead center, and then we can use a strobe light to look at it. And all the way in the bottom there, you can see the big white marker and the smaller ones. Well, the big one is my top dead center, and I positioned my engine so that the flywheel marking is exactly top dead center. So now I know that this pointer on the distribution cover is correct. I also have a dot on my crankshaft pulley, and it actually lines up. The small little dots that you see, that's each time 4 degrees advance. So the first one is 4, the second one is 8, and so on. Now that's the case on this Mini. On your car that might be different, but that's kind of irrelevant. Just check your manual on your car to see where your markings are. But on the Mini, this is how you can verify it. And I do recommend that you do verify this way before you even start, because I've seen quite some offsets on this before. And this is going to be a little bit difficult because I don't have a lot of light inside. But over here, that's the clamp that is holding the distributor. So I'm going to loosen that up a little bit, and then I will rotate the distributor to make sure that my timing marks are set to about 10 degrees advance or something like that with my strobe light. Now don't make it too loose either, guys, because that's not good. Loose enough so you can actually rotate the distributor. So that should be loose enough. Now we need to hook up my strobe light. So the strobe light is going to go to the plus 12 volts, and I'm going to pick it up from the starter relay, and the other clamp is going to the ground to make sure you have a good ground. And then you have the clamp that's going to pick up the spark, and you typically have an arrow on it pointing towards the spark plug. So put it on like that on the first cylinder, and on the Mini the first cylinder is the spark plug closest to the radiator, and then we are about ready to start it and have a look inside with the strobe light what's going to happen. Now on this strobe light I have something what we call advance, so I can set the advance myself, so it will calculate it. So if I set my advance to 10 degrees on this device, then it will still flash at top dead center. So this is a nice feature of this strobe light. So you might want to get a strobe light like this, because it's very handy, because it's going to come in very handy once we start testing the dynamic advance. So let me start the engine and then see where the setting is at this moment in time. So make sure that the engine is running at sufficient idle speed. Alright, so now I will use my flashlight and you will see the flashes. You see that? And I'm going to shine inside the engine and see where I am. I'm going to adjust my distributor by rotating it until I have the right amount of degrees. 8, 9 degrees advance. So for me that is good. I'm going to keep it that way. With this strobe light I can actually set the advance in degrees. So I can set it to, like, 8 degrees, and I should see the point moving on the pulley then. But right now I'm going to set it to 0. I'm going to flash one more time inside, increase the degrees on my strobe here, and I should see the mark on my pulley moving forward and lining up actually with 0 or top dead center. And what I see here is I have about 10 degrees advance, as you can see, and that's the advance I wanted to get. So once you rotated the distributor, that the marks on your pulley lined up exactly on the amount of degrees that you want to have for your static advance, all you need to do is shut down the engine and tighten down that bolt and lock that distributor into place, and then start the engine again and do a double check if nothing moved. That still looks like spot on. The next step is, of course, now checking the dynamic advance. But for that, I'm going to hook up, first of all, again, my vacuum hose onto my distributor. That's one. And that goes to the intake manifold, which is over here. So I want to make sure that it all fits nicely. So now we're going to check the dynamic advance. And the way that is done is you use your strobe light, you look at your pulley, and then you increase the RPMs. So have someone to push the throttle or whatever to a certain amount of RPMs. You need to know what the RPMs are, and then you can actually see where the marker is on the pulley on how much degrees advance you have. And you can do this in multiple steps, 1,000, 2,000, 3,000, 4,000 RPM, the way you like to do it, and you can actually plot it so you can create your own curve. It's a bit difficult if the advance is going off the scale actually of your pointers. So what we're going to do now is to check the dynamic advance, and for that one you're going to need the strobe light for sure. There's no other way around of doing it. I hooked up the vacuum hose already, so I'm going to crank up the engine. I'm going to run it at 1,000, maybe 2,000, 3,000. I will run it in incremental steps and have someone to do that, or you adjust the gas throttle yourself. It's all up to you. And then I'm going to use the strobe to light up the markings on my crankshaft pulley and on the fingers on the distribution cover in this case. But the problem you're going to run into is that you're not going to have enough markers on these fingers on that distribution case to indicate a 21 or a 32 degree advance. So that's why a strobe light that you could use with an advanced control is very, very handy, because now I can set the delay in the strobe to X amount of degrees. So if I'm looking at this marking, I'm using the strobe light to look on where my marks are, and I'm turning this knob until the point whereby my top dead center marker and the marker on my pulley line up, then I can read out the advance here on this display, and then I know exactly how much advance I have. And that's a very easy and handy way to do it. So I'm going to start the engine, and I'm going to crank it up to X amount of RPMs, and I will measure it. So let's have a look how many RPMs we now have. And right now I have about 1,500 RPMs. I'm going to change that a bit to about 2,000. And as you can see, it's increasing. Okay, that's close enough. And now I'm going to check on my marks and adjust the delay. And for that one, I need to select the advance, right? So there we go. So right now it's set to 0. I don't know what it will be. So let me check. So let me check this and adjust it. And I have about 20 degrees advance at this rate. So now I'm going to increase the RPMs to the next level and see how much we're going to get. So let's check the RPMs and crank it up a bit more. So 3,000 RPMs, so let me check again. And I'm having about 33 degrees. So I'm going to set it back now to about 1,000 RPMs. So what I just showed you was a little bit loud, so maybe you could not hear what I was saying, but I've been revving up the engine to different RPMs, 2,000 and 3,000 RPM, and then I used my flashlight and I adjusted my retardant, the knob, until my marker or my pulley lined up with the pointer of top dead center on my distribution cover. And by doing so, I could then read the actual amount of degrees that I had to set to line that up. And that is actually my advance, or my total advance, which is my dynamic advance, but also my static advance added together. And you could see by the end I was nearing to where I wanted to be, 32, 35. I was a bit on the high side. So now I should take the car for a test ride, go uphill, floor the pedal, and then see if we have any pinging. So far it was going very well, but of course this is under load. If the engine pings, then I'm going to reduce my static advance, which is 10 degrees. I'm going to probably set it then to 5. But I know that this setting is working just fine because I've tested this car before. We are nearing the end of this video, and I really hope that you enjoyed this video as much as I did. We've done a lot of things, and it's not always easy to show all the details, especially on a small car like this where you barely can get into the crankshaft pulley and see things, but hopefully you got the idea and the principle on how we are doing this. So to conclude, a little recap of what we have done. First of all, we talked a bit about the precondition on the condition of the engine, the condition of the spark plugs, the condition of the carburetor, all that before you even start to adjust the ignition timing. Then we corrected the dwell angle, which is very important to have a very strong and solid arc or spark, whatever you want to call it. And then we moved on to the static adjustment of the distributor by rotating the distributor to the desired amount of advance. And you do this by disconnecting your vacuum if it's a vacuum assisted distributor. I've set mine to about 10 degrees. Yours may be 5 or something else, but 10 degrees is a pretty good figure. You might want to go for 8. It all depends a bit on your car. Check in your manual what your settings should be, but in my case, 8 to 10 is quite all right. And then we moved on to the dynamic adjustment. We looked at how that works with the bob weights and the springs, how you can tune your curve with those. And then we also looked on the vacuum-based distributors. We tested it on the Mini. We actually checked the vacuum, but we also did check on the advance that would happen while we're running at higher RPMs. And this is the dynamic advance. And we use the strobe light for that, where you can put the advance in, or the retardant of the flash, basically. And we use that to align the marking on the pulley to top that center on the pointer because the flash is delayed in the strobe light. And you can set it, and then you can actually read when these two markers line up. You can actually read what the actual advance is in amount of degrees. On this specific card, I think we ended up around, what was it again, 20 degrees or so at 2,000 RPM, and we ended up at around 34 degrees at 3,000 RPM. So for me, that is good. And at the end, you always should do a road test and make sure the engine doesn't start to ping, because that would be bad for your engine. So I hope to see you in my next video, and those of you that really like Old Rusty, have some good news. I was told that my parts will arrive next week to fix the carburetor, so we can actually crank up the engine for the first time. Thank you for viewing, and please by all means provide comments. Bye bye.